All right, we're going to go ahead and get started talking about this SI system, and we're going to be specifically looking at some of the units of measurement. Today, specifically, what you're going to be looking at, TLW just stands for the learner will, so you're going to define some of the common base units. We're going to explain how adding a prefix is going to change a unit, and we're going to compare derived units for volume and density. The SI system. Science is going to be an investigation of the world. We're talking medically, we're talking physically, we're talking chemically, we're talking earth science. All kinds of investigation is going to be going on. A couple different kinds or types of data. There's quantitative data, and just like that prefix or that word out in front there, you see the word quantity. Quantity just means numerical. So what we're talking about here is numerical data. So we could say 150 pounds. We could say 24.5 degrees Celsius. We could say 34 degrees northwest. Okay, that's all numerical data. Qualitative data, that's descriptive. It's hot in here. It's cold in here. In science, quantitative data is going to be the most important. The problem is with qualitative data, it's argumentative. You know, a lot of people in my room will say, oh, it's hot. Some people say it's cold. Some people say it's just right. Again, who's right? In quantitative data, if I ask somebody to go back and record the temperature of the room, there really shouldn't be any discrepancy whatsoever. Everyone's going to read really the same numerical value. The International System of Units, more commonly known as the SI system, basically it comes from France, and what it is when you think of the language, it's La Système International. Okay, La Système International. That's where SI comes from. Again, we just go ahead and talk about it as an international system of units. It was developed in 1960, like I said, in France, and basically what it did is it created some base units that's going to allow everyone worldwide to go ahead and measure in the same units without having to do lots of changes or conversions. The other thing to probably tell you about this SI system, it really has taken over the world. There's only really one major country, that's the United States. We still measure things in miles. We still measure things, in gallons and things like that. And there's actually two kind of small independent nations or countries that use the same system as the United States, but otherwise everyone else worldwide, they measure in kilometers. They're measuring in milliliters or liters and things like that. So the United States kind of holding on to their own system, but like I said, everyone else pretty much in the world is using this SI system. It came up with some common base units. There's going to be 7 of them that I'm going to want you to know for this chapter, for quizzes, for tests, things like that. And they are: time is going to be measured in seconds. Length is going to be measured in the meter. Mass is going to be measured in kilograms. Temperature is going to be measured in Kelvin. Now again, when you think of temperature, we go outside and we say, well, it's 82 degrees Fahrenheit. You go anywhere else in the world and they measure things in Celsius. The Kelvin scale was a scale that was created that eliminated all zero values and it eliminated all negative values. And you might be asking yourself, well, why is that so important to eliminate zero and negative values? The problem is it comes with the math. There will be equations that we have where you divide by temperature, and you can't divide by zero. And like I said, we can get down to 0 degrees Fahrenheit. We can get down to 0 degrees Celsius. And like I said, in math, you can't divide by zero. So they had to come up with a scale that was going to eliminate that zero number. And so the scale that they came up with is the Kelvin. The amount of a substance, that's going to be measured in moles. Electric current is going to be measured in amperes, and luminous intensity is going to be measured in candela. When you think of luminous intensity, here's kind of my hint. Luminous intensity means light. What do you do to light up a room? Light a candle. Okay, so candela. Talking a little bit more about the SI system. The other thing that the SI system did, other than come up with some common base units, they came up with a system that also allowed them to represent very large and very small quantities. What they did is they came up with some SI prefixes. And what I'm going to do is I'm going to list them from largest to smallest. Giga. Giga just means 10 to the ninth. Mega is 10 to the sixth. Kilo is 10 to the third. Deci is 10 to the negative 1. Centi is going to be 10 to the negative 2. Milli, 10 to the negative 3. Micro, 10 to the negative 6th. Nano is 10 to the negative 9th. And pico. Pico is going to be 10 to the negative 12th. This is also going to be a very important set of prefixes that you're going to have to know when we get into a lot of our conversions that we're going to be doing over the next few days. So it's going to be important that you recognize the prefix and know the power of 10 that goes with it. Because without knowing this power of 10, you're not going to be able to do any of the conversions. Like I said, I'll let you know, but we're going to be having a quiz over the base units and a quiz over using these prefixes. So you're gonna have to know these. Now the thing is, SI didn't define everything. Okay. Yes, they did come up with some common base units, but they said, you know what, you can go ahead and put some of these base units together to define some of the others, or you can derive your own. Derived units are just going to be units that can be found by pairing base units together. For example, speed. Speed is just going to be distance divided by time. Distance is a length. Length, we said, is measured in meters. Time was measured in seconds, so you get meters per second. A Newton. A Newton is just going to be a measure of a mass over an acceleration, okay, or compared to an acceleration. So mass, we had it in kilograms. Acceleration, well, that's in a meter per second squared. So the thing is, we can say that a Newton is a derived unit that is a kilogram multiplied by a meter divided by seconds squared. So like I said, SI did not define all units. They said we can go ahead and pair some of these base units up and you can derive some of these other units on your own. And there's going to be numerous derived units, but like I said, they're not specifically defined by SI. Volume is going to be another derived unit that is based on 3 lengths. When you think of any of the equation for volume, it's length times width times height. Or if you have a perfect cube, it's going to be your side cube. But again, it's 3 lengths. So if we use the meter, you know, length times width times height, or a meter times a meter times a meter, you're going to end up with a meter cubed. Now, a meter cubed is actually a very large volume to work with. So what they did is they scaled it back. And the common ones that we're going to be using in chemistry are going to be liters, decimeters cubed, centimeters cubed, and milliliters. This conversion is going to be one that you're going to want to keep in the back of your mind. We're going to be using this conversion a lot this year. So if you're putting it in your notes, know where it's at so you can make reference to it later on. Like I said, you know, we'll use it tomorrow. We'll use it in a month. We'll use it basically, like I said, in February, in March, April, May. So this is going to be something that you have to remember. But if you notice here, 1 liter is 1 decimeter cubed. Liters and decimeters cubed are exactly the same. Now let's come over here. 1,000, 1,000. So what we're saying is 1,000 centimeters cubed is equal to 1,000 milliliters. Centimeters cubed and milliliters are exactly the same also. So 1 liter is 1,000 centimeters cubed. 1 liter is 1,000 milliliters. 1 decimeter cubed is 1,000 centimeters cubed. 1 decimeter cubed is equal to 1,000 milliliters. So like I said, I cannot probably stress this conversion enough, because again, we're going to go through some other conversions tomorrow, but the thing is, those are going to be working with a factor label method or a dimensional analysis. This is going to be a special set that you don't have to use the dimensional analysis that we're going to be talking about. Density is another derived unit that's going to be based on an object's mass and its volume. The thing is, this is a physical property. Okay, density is a physical property for a substance. For example, iron. Iron will have a certain density. Okay, you're never going to find iron's density being anything else. For example, water. Water has a density of 1.0 grams per milliliter, or 1.0 grams per centimeter cubed. It's never going to be different. Okay, it's always going to be 1. Aluminum. It'll have its own density. Okay, steel will have its own density. So it is a physical property that depends on the substance itself. Density is just going to equal mass divided by volume. Okay, if you want to look at the letters, D equals M divided by V. Mass will have to be measured in. Okay, looking here, I know I have down kilograms. I was getting ahead of myself. Mass is going to be measured in grams. Okay, so get rid of the K. Okay, so mass is measured in grams. Volume is going to be measured in milliliters or centimeters cubed. So this one actually is correct. Density is going to be measured in a gram per milliliter or a gram per centimeter cubed. And the reason why I can put both of these down, because if you remember back to that previous slide where I said 1,000 milliliters, and I said 1,000 centimeters cubed, and we said milliliters and centimeters cubed are exactly the same thing. So grams per milliliter or grams per centimeter cubed. Again, I want to go back and remind you, mass is measured in grams, not kilograms. The Kelvin scale was created, like I said, to eliminate all zero and negative values. And a conversion that you're going to need to know between Kelvin and Celsius is, to go to Kelvin, you're going to take the Celsius temperature and add 273. To go to Celsius from Kelvin, you're going to take that Kelvin temperature and you're going to subtract 273.